Hello everyone, this is a course on General Aptitude for GATE 2026. In this session, we'll see the topics, the number of trailing zeros, cyclicity and unit digit in detail. So let's get started. Number of trailing zeros. Sometimes we come across problems in which we have to count number of zeros at the end of factorial of any number. For example, 10 factorial. We'll have to find the number of zeros at the end of 10 factorial. So what we have to do is, here basically we have to count the number of 5s. Okay, to find number of zeros at the end of 10 factorial, we have to count the number of 5s, because 5 multiplied by any even number will give a 0 at the end. That is 5 into 2 gives 10, 5 into 4 gives 20, 5 into 6 gives 30, etc. That is 5 multiplied by any even number will give a 0 at the end. So to find the number of zeros at the end of any factorial number, basically we have to find the number of 5s. Okay, now we can find the number of zeros at the end of 10 factorial. What is 10 factorial? 10 factorial is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So we'll count the number of 5s in 10 factorial. There is 1 5. Okay. Now there is another 5 where here, that is 10 is 5 into 2. Okay, 10 is equal to 5 into 2. So we got another 5. So how many number of 5s are there? Number of 5s in 10 factorial is 1, 2. That is 2. That is equal to the number of zeros. Okay, therefore the number of zeros is also equal to 2. Therefore, to find the number of zeros at the end of any factorial number, we have to find the number of 5s in that factorial. Okay, then now we have a shortcut method to find the number of zeros at the end of any factorial number. To find number of zeros at the end of n factorial. The shortcut method is that is equal to n by 5 plus n by 5 square plus n by 5 cube plus n by 5 raised to 4 plus etc. Here we have to note that we have to take only the integer values. Okay, now we'll solve the problem. Find the number of zeros at the end of 100 factorial. Find number of zeros at the end of 100 factorial. So what we'll have to do, use this shortcut method. Here n is equal to 100. 100 by 5 plus 100 by 5 square plus 100 by 5 cube plus etc. Okay. Now see that what is 100 by 5? 100 by 5 is 20 plus 100 by 5 square, that is 100 by 25. 100 by 25 is 4. Next is 100 by 5 cube, that is 100 by 125, that is point something. So we don't have to take the decimal value. This is 0. Therefore, the number of zeros at the end of 100 factorial is 24. This is the way to find the number of zeros at the end of any factorial number. Now we'll see another problem. Find the number of zeros at the end of 126 factorial. Find number of zeros at the end of 126 factorial. So again we'll use the formula 126 by 5 plus 126 by 5 cube plus 126 by, here it is 5 square, next is 5 cube, then 126 by 5 raised to 4 plus etc. So what is 125? 126 by 5. We know that 125 by 5 is equal to 25. Then what will be 126 by 5? 126 by 5 will be 25 point something. So we'll have to take only the integer value. So we can write it as 25 itself. Next is 126 by 5 square. That is 125 by 5 square is that is 125 by 25, which is equal to 5. So 126 by 25 will be 5 point something. So we'll take only the integer value, which is 5. Okay. Next is 126 by 5 cube. 5 cube is 125. This is equal to 1 point something. So we'll take the integer value 1. Now this is equal to 31. So the number of zeros at the end of 126 factorial will be equal to 31. So the next topic is cyclicity. Cyclicity of a number is used mainly for the calculation of unit digit. Okay. To find the unit digit, we'll use this concept of cyclicity. Okay. First we'll see the cyclicity of 1. Cyclicity of 1. We know that 1 raised to any number gives 1. Okay, 1 raised to n is equal to 1. So the unit digit will be always equal to 1. So unit digit is always equal to 1. Next is cyclicity of 2. Okay, here we know that what is 2 raised to 1. The next slide will write this. 2 raised to 1 is 2. 2 square 4. 2 cube 8. 2 raised to 4 is 16. Next is 32. 2 raised to 6 is 64. 2 raised to 7 128. 2 raised to 8 equal to 256. So we'll check the unit digit. Here the unit digit is 2, 4, 8, 6. Now again we can see the unit digit as 2, 4, 8, 6. That is a number 2, 4, 8, 6. These numbers are repeated after every 4 intervals. Okay. After every 4 intervals, these 4 numbers are repeated. So this can be used to find the unit digit. So what is a unit digit? That is, find the unit digit of 2 raised to 323. Find the unit digit of 2 raised to 323. We know that 2, 4, 8, 6 repeat after every 4 interval. Okay. So what we have to do is divide this power by 4, because these numbers are repeated after an interval of 4 numbers. Therefore divide 323 by 4. What we'll get? 8 4s are 32 and the remainder will be 3. See this remainder. Now replace this 323 by this remainder, that is 2 raised to 3. What is 2 raised to 3? 2 raised to 3 is 8. Therefore the unit digit of 2 raised to 323 is equal to 8. This is how we find the unit digit. Okay. We'll see one more example. Find the unit digit of 12 raised to 12 into 22 raised to 22. 22 raised to 22. First we will see 12 raised to 12. Take 12 raised to 12. Here the unit digit is 2. So we know that for 2, what happens? The 4 numbers that we just discussed now, 2, 4, 8, 6, that repeats itself after an interval of 4 cycles. Therefore first step is to divide this power by 4. 12 divided by 4. We get remainder as 0. So if we get a remainder as 0, what we have to do is write this 12 power as 4. Okay. if we get the remainder as 0, we have to write the power as 4, not 0. Okay. So what is this? What is this? That is 2 raised to 1 is 2, 2 square is 4, 2 cube is 8, 2 raised to 4 is 16. So 12 raised to 4 will have a unit digit of 6. This is how we find the unit digit of 12 raised to 12. Next we will find the unit digit of 22 raised to 22. 22 raised to 22. First step is to divide 22 by 4. 22 divided by 4 gives 5 4s are 20, remainder as 2. So what we have to do is replace this 22 by 2. That is 22 raised to 2. So what is 2 raised to 2? 2 raised to 4, 2 raised to 2, the unit digit is 4. So here for 22 raised to 22, the unit digit will be 4. Next step is multiply these two. That is 6 into 4. 6 into 4 is 24 and the unit digit will be 4. Okay, so here the answer would be 4. This is how we will find the unit digit. This is the cyclicity of 2. Next is cyclicity of 3. Here also we will find the unit digit. First, we can write 3 raised to 1 is 3, 3 raised to 2, 9, 3 cube, 27, 3 raised to 4, 81, 3 raised to 5, 243, 3 raised to 6, 729, 3 raised to 7, 2187, 3 raised to 8, 6561. Here the unit digit is 3971. After an interval of 4, again it repeats 3971. So the numbers 3971 repeats itself after a cycle of 4. So to find the unit digit number of 3, okay, what we have to do is divide the number by 4. That is, for example, we can see, find the unit digit of 133 raised to 133. Find unit digit of 133 raised to 133. Here the unit digit is 3 and the power is 133. So we know that these 4 numbers are repeated after a cycle of 4. Therefore, in the previous case also what we did, divide the power by 4. 133 divided by 4. 3 4s are 12. Again 3 4s are 12. Remainder would be 1. Now next step is replace this 133 by this remainder. That is, this is equal to 133 raised to 1. So here this is 3 raised to 1. What is the unit digit of 3 raised to 1? This is 3. Therefore the unit digit of 133 raised to 133 will be equal to 3. This is the final answer. Next is cyclicity of 4. Okay, here what is 4 raised to 1? 4 raised to 1, 4. 4 square is 16. 4 cube, 4 raised to 4. 4 cube is 64. 4 raised to 4 is 256. Now check the unit digit. 4 raised to 1 is 4. Next is 6. Again 4, again 6. So what we can see? 4 raised to n. That is, when this n is odd number, that is 1, 3. When n is odd, then the unit digit is, when n is odd, the unit digit is 4. When n is odd. Next, when this n is even, that is 2, 4. What happens? The unit digit is 6. Here the unit digit is 6 when n is even. So this is the cyclicity of 4, that is 4 raised to n. For 4 raised to n, the unit digit is 4 when this n is odd and it is 6 when n is even. So using this we can find the unit digit of 4. Example, find the unit digit of 4 raised to 1024. 4 raised to 1024. So here the number is 4. So see the power. This is n. Is this power odd or even? This power is 1024 is even. So when 4 raised to 1 is 4, 4 raised to 2 is 16. That is for even power the unit digit is 6. So here the unit digit will be 6. This is the answer. We'll see one more question. Find the unit digit of 133 raised to 63. 133 raised to 63 into 4 raised to 49. 4 raised to 49. First we'll see 133 raised to 63. Okay. What is this unit digit here? It is 3. So we'll have to use the cyclicity of 3. In cyclicity of 3, how we found the unit digit? First we divided this power by 4. 63 divided by 4. That is 23. Remainder is 3. Now next we have to do is replace this 63 by 3. Okay, this remainder. Now what is 3 raised to 3? We know that 3 raised to 1 is 3. 3 square is 9. 3 cube is 27. So what is the unit digit here? The unit digit is for 3 cube is 7. So 133 raised to 63 will have a unit digit equal to 7. This is the first term. Next we'll see the second term, 4 raised to 49. So here the number is 4. Here the unit digit is 4. So we have to use the cyclicity of 4. In cyclicity of 4, what we did? See the power of this 4. And if this power is odd, then the unit digit will be 4. Here 49. This is an odd number. Therefore, the unit digit will be equal to 4. So 4 raised to 49 will have a unit digit equal to 4. Next is, we found out the unit digit of 133 raised to 63 and 4 raised to 49. Now we have to multiply these two. That is 7 into 4. Therefore, the unit digit will be 7 into 4. What is 7 into 4? 28. And what is the unit digit? Unit digit is 8. So 8 is the final answer. This is the answer. This is how we'll find the unit digit using the cyclicity concept. Next we'll see the cyclicity of 5. Cyclicity of 5. 5 raised to 1, 5. 5 raised to 2, 25. 5 cubed, 125. 5 raised to 4, 625. See that the unit digit is always equal to 5. Unit digit is always equal to 5. In the case of 5, the unit digit is always equal to 5. So this is a simple concept. Next will be the cyclicity of 6. 6 raised to 1, 6. 6 square, 36. 6 cube, 216, etc. Here again we see that the unit digit is always equal to 6. In the case of 6, the unit digit is always 6. So for the cyclicity for 6, unit digit is always 6. Now we will see a problem related to this. Find the unit digit of 5 4 raised to 69, 4 raised to 69 into 6 raised to 5. Okay, first term is 4 raised to 69. Here we have to use the cyclicity of 4. Second term is 6 raised to 5. Here we have to use the cyclicity of 6. So in 4 raised to 69, how we did the for 4? That is, see the power. If the power is odd, then it's 4 raised to 1. 4 raised to 1 is 4. That is, when the power is odd, then unit digit will be 4. So here seeing the power is odd, therefore the unit digit is equal to 4. Next is use the cyclicity concept of 6. For 6, the unit digit is always equal to 6. Whether any power we take, the unit digit will be always equal to 6. Now what we have to do? Multiply these two numbers, that is 4 into 6. 6 4s are 24, and see what is the unit digit here. The unit digit is 4. Therefore final answer is equal to 4. Okay, this is, now we have did the cyclicity up to 6. Next we'll see the cyclicity of 7. Cyclicity of 7. 7 raised to 1, 7. 7 square, 49. 7 cube, 3, 4, 3. 7 raised to 4. 2, 4, 0, 1. 7 raised to 5. 16807, 7 raised to 6, 117, 649, 7 raised to 7, 823, 543, etc. So here also similar to 2 and 3, similar to how we did in 2 and 3, that is 7, 9, 3, 1, 7, 9, 3, next will be 1. So the number 7, 9, 3, 1 repeat itself after a cycle of 4. Okay. Now find the unit digit of, solve this problem, find the unit digit of 17 raised to 17 into 27 raised to 27, 27 raised to 27. Here the unit digit is 7. So we have to use the concept of cyclicity of 7. So we know that here the 7931 repeats itself after a cycle of 4. Therefore what we have to do? First we take 17 raised to 17. Now divide this power by 4. 17 divided by 4. 4 4s are 60 and the remainder is 1. Now this is equal to 7 raised to 1. What is 7 raised to 1? 7 raised to 1 is 7. So the unit digit is equal to 7. In this case the unit digit is equal to 7. Next we will take the second term, 27 raised to 27. 27 raised to 27. Again we will divide this power by 4. 27 divided by 4, that is 6 4s are 24, remainder is 3. So replace this power by 3, that is 27 raised to 3. What is 7 cube? 7 cube is 343. 7 cube is 343 and the unit digit is 3. So here the unit digit is 3 in the second case. Here the unit digit is 3. And for the first case, unit digit we got as 7. Next we have to multiply these two. 7 into 3. 7 into 3 is 21 and the unit digit is 1. Therefore the final answer is 1. Here the final answer is equal to 1. This is the cyclicity of 7. Next is cyclicity of 8. This is also similar to 7. Here if we write 8 raised to 1, 8 raised to 2, 8 raised to 3, etc. we can see that the numbers 8, 4, 2, 6. This number repeats itself after a cycle of 4. So again what we did with 7 you repeat with 8 also. Okay, now we'll see a problem for 8, cyclicity of 8. That is, find the unit digit of 18 raised to 18 into 28 raised to 28 into 288 288. Here all the unit digits are 8. So we'll use the cyclicity of 8. So in this case also, first take the 18 raised to 18, first number 18 raised to 18. Next is divide this power by 4, that is 18 divided by 4. Remainder is 2. Now replace this power by 2, that is 18 raised to 2. Now what is 8 square? 8 raised to 1 is equal to 8. 8 square is 64. 8 cube 512. 8 raised to 4 4096, that is 84296. These numbers are repeated. So 8 square is the second one, that is 64, and the unit digit is 4. Unit digit is equal to 4. Next we'll take the second term, 28 raised to 28. 28 raised to 28. Again divide 28 by 4. 28 divided by 4. That is 7 4s are 28. You get remainder 0. So when we get the remainder as 0, take this power as 4. Okay. That is 28 raised to 4. That is 8 raised to 4. What is 8 raised to 4? 4096. That is the unit digit is 6. And the third term is 288 raised to 288. 288 raised to 288. Now again we divide 288 by 4. 288 divided by 4. 7 4s are 28. 4 2s are 8. Again the remainder is 0. When the remainder is 0, we have to take the power as 4. That is 288 raised to 4. What is 8 raised to 4? 8 raised to 4 is 4096. Again the unit digit is 6. Next step is to multiply all these unit digits. That is 4 into 6 into 6. So the unit digit is 4 into 6 into 6. That is equal to 144. And what is the unit digit here? The unit digit is 4. So the final answer is equal to 4. This is how we find the unit digit. Okay, that is about cyclicity of 8. Next we see the cyclicity of 9. Cyclicity of 9. This is similar to 4. That is 9 raised to 1 is 9. 9 square is 81. 9 cube 729. 9 raised to 4 is 6561. Here the numbers 9 and 1. 9 and 1. So when the power is odd, then the unit digit is 9. When n is odd. And the unit digit is 1 when the power is even. When n is even. This is how we find the unit digit of 9 raised to n. That is, the unit digit is 9 when n is odd, and unit digit is 1 when n is even. This is similar to that we did in for 4. Okay. We'll solve this problem. Find the unit digit of 11 raised to 11 plus 12 raised to 12 plus 13 raised to 13 plus 14 raised to 14 plus 15 raised to 15. Okay. First we'll take the term 11 raised to 11. Here see that here the unit digit is 1. For 1 the unit digit is always equal to 1. Therefore here the unit digit of this term is equal to 1. Next is 12 raised to 12. Here the unit digit is 2. For 2 The cyclicity is 4, therefore divide this numerator power by 4, that is 12 divided by 4, and the remainder we get as 0. So when we get remainder as 0, we will take the power as 4, that is 12 raised to 4. Then what is 2 raised to 4? 2 raised to 1 is 2. 2 square 4, 2 cube 8, 2 raised to 4 16. Therefore this is 2 raised to 4 is 16, and here the unit digit is 6. For the second we get the unit digit as 6. Now take the third term, 13 raised to 13. Here we have to see the cyclicity of 3. Again here also we divide 13 by 4. 13 divided by 4. 4 3s are 12, remainder is 1. So we can take it as this 13 raised to power is this one, that is 1. That is 3 raised to 1. What is 3 raised to 1? 3 raised to 1 is 3. Therefore the unit digit is 3. Here the unit digit is 3. Next is 14 raised to 14. In the case of 4, what we did? 4 raised to n is 4 when n is odd, and 4 raised to n is, the unit digit is 6 when n is even. Here the power is even number, therefore the unit digit is equal to 6. Therefore here the unit digit is 6. Next is 15 raised to 15. Here for 5 we know that the unit digit is always equal to 5. For any power, unit digit is 5. Therefore this unit digit is 5. Next what we have to do is add all these numbers, that is all these unit digits, that is 1 plus 6 plus 3 plus 6 plus 5, which is equal to 21. And what is the unit digit here? The unit digit is 1. Therefore the final answer is equal to 1. This is the unit digit. So this is how we find the unit digit of any expression. So we'll summarize this concept of cyclicity using the cyclicity table. First is 1, 2, 3, 4, 5, 6, 7, 8, 9. For 1, we know that the unit digit is always equal to 1. Again for 5, the unit digit is always equal to 5. For 6, the unit digit is always equal to 6. Now for 4, the unit digit is equal to 4 when the power is odd, and the unit digit is equal to 6 when the power is even. Next is 9. The unit digit is equal to 1 when the power is odd. The unit digit is 9 when the power is odd, and it is equal to 1 when the power is even. Next is for 2, 3, 7, 8. For 2, 3 and 7, 8. For 2, the numbers 2, 4, 6, 8. These numbers repeats itself after a cycle of 4. Next is 3, 3, 9, 7, 1. These numbers repeats itself after a cycle of 4. For 7, 7, 9, 3, 1. For 8, 8, 4, 2, 6. This is the cyclicity table.